Good morning. Good morning, Sterling. Good morning, Kyle.
Good morning.
Thank you so much for joining us today. I'll let you introduce yourself, but Kyle is the VP and Chief Technology Officer of PACCAR, one of the biggest trucking companies in the world. And Sterling is the Chief Product Officer at Aurora Innovation and one of the pioneers of autonomous driving. We're just really, really honored that the two of you graciously agreed to be on our panel. Both got incredible experience. It was nice when I Googled Sterling. He was one of the few other speakers we've got who's actually got research publications. That's wonderful. But with that, Kyle, let's start with you. Tell us a little bit about PACCAR and sort of what is the impetus for moving into sort of autonomous vehicles in the trucking industry?
Okay, thanks, Vijay. So PACCAR is a 115-year-old company based in Bellevue, Washington. We're a global leader in the design, manufacture, and support of premium, medium duty, and heavy commercial vehicles. We've been in the business a long time. We build a lot of vehicles every year, and the way we see autonomy is that it's one of the largest changes and most significant new technologies to come to the automotive space and commercial trucking in particular in a long, long time. And so we think it's a powerful opportunity, and it's something we have to be involved in and pay attention to.
Yeah, and it's a really challenging set of technologies as well, obviously. So Sterling, tell us the story behind Aurora, because I think it's a really powerful story. The co-founders that you included and the two others have incredible backgrounds, and you have a really sort of, in my view, wonderful vision for where the future of autonomy lies.
Sure, yeah. Aurora's been around for about 4 years. We started in late 2016, early 2017. Myself, Chris Urmson, who led Google's self-driving group, Drew Bagnell, who led Uber's, and I was leading Tesla's at the time. We came together to form Aurora with the expectation that we would create a company and a product that would deliver the benefits of self-driving technology safely, quickly, and broadly. And we recognized just how challenging this problem was. Each of us had a little bit of the benefit of hindsight from having developed this for many, many years. The other two at Carnegie Mellon, myself at MIT, some of the work that we did at Google, Tesla, and Uber gave us a perspective of what the industry needed in terms of both the technology, but also commercial structures that would allow us to deliver these benefits safely, quickly, and broadly. So we came together to form this, and we built the company on the premise that an extremely strong and selective team built of folks who deeply understood the technical challenge involved here, in partnership with the industry, specifically those both on the partner or the auto manufacturer side, but also those on the kind of the customer side, be that the fleets, the carriers, the ride-sharing companies, could build an ecosystem that would allow us collectively to deliver the benefits of this technology safely, quickly, and broadly. And so we've made tremendous investments over the last several years as we've built the company and built our product. We're still a few years from commercialization of that product, but we've designed it to be agnostic to platform and use case. And what that means is we've developed it in such a way that we can move it between vehicles with a simplified vehicle interface and an abstraction layer that allows us to keep the core of the self-driving system, which is extraordinarily complex and difficult to validate, intact. And so that as we port it from a Class A truck to a light commercial vehicle to a passenger vehicle, we're able to retain the safety guarantees of the driver, and provided the vehicle platform has been built to the specifications of the driver, can then build a safety case that allows us to deliver the technology. So that's kind of the approach that we've taken. We're focused on the movement of both goods and people, but we believe there's an appropriate order or sequence to these things. And so our path to market looks like, first, heavy trucking, middle mile, long haul logistics applications for several reasons we can get into if it's interesting, followed by local goods delivery, so last mile type delivery, followed by mobility services or ride sharing, the kind of movement of people. So yeah, that's a little bit about Aurora and why we founded it.
And that's really interesting because so often there's so many things I want to touch on, and we only have a little bit of time, but I'm going to touch on a few. So often we talk about first mover advantage, but when you have a very long life cycle, as the case might be for autonomous vehicles, it may not, I hear you saying you actually learn from, the three of you learned from your prior experiences and it sort of brought some insights that you could build into new product. The second thing I want to touch on, and I'll ask them both together, and that's, I think, is one of the beauties of software, which is, these platforms are extremely, well, they can be very complex, of course, but they're also flexible so that you have I think people don't necessarily understand sort of the interrelationship between your technology platform and the strategies that it permits. And what I'm hearing you say is if you have a common enough core with some customization by use case, and I'm abbreviating here, you can actually figure out your market entry strategy. So talk to us a little bit about sort of the technology piece, like what's the challenging part of this? At some level, everybody understands that this is really hard stuff, but given where you sit with so many competitors who are all pretty darn good, I would assume, like what's the nuttiest thing, what's the hardest nut you have to crack?
Yeah. To give a little bit of context as to kind of the scope and nature of the challenge, you have to look at kind of the current best alternative, which is a human driver. And on the roads today in the United States, the human driver is a fatalities experience once out of every approximately 90 million miles traveled. If you take the average kind of miles traveled by an American per year, you're talking over 100 lifetimes of driving before a single fatality is incurred. Right? So we colloquially like to joke about how humans are terrible drivers, but if you consider for a moment that over 100 lifetimes are driven between a single fatality, and you think about, okay, how many weird cases were experienced in 100 lifetimes of driving that would just be extraordinarily challenging to deal with, you start to get a little bit of a sense for just the combinatorial complexity and kind of the nature and scope of the burden of proof, which is extraordinary. To statistically show evidence that you have satisfied that you're at least as good as a human, and we believe the appropriate bar is better than a human before you deploy in commerce, you need to have proven statistically that you best what is already a fairly extraordinary performance record. The second part of it, beyond the kind of the burden of proof that's quite high, is the combinatorial complexity of roadways that are shared with humans. Right? So every moment when you or I are on the road, we are forward predicting the future motion and intentions of every other actor, whether it's a bicyclist, a pedestrian, another motorist, and we're tweaking those in real time, those predictions, based on many observations that we're making. Whether we're seeing kind of where the driver is looking, we understand kind of what the nature of the road rules are in a particular case. But the fact of the matter is, combinatorically, there are infinite possibilities for what could actually play out on the road. And so for a self-driving system to safely navigate this at a better safety record than a human, we have to appropriately both understand who's around us, and that's kind of a perception problem as it relates to sensors and perception techniques. And we have to even more importantly than that, predict accurately how they're going to move in the future and make our decisions on the basis of that. So that's kind of at the heart of the challenge is around sensing, perception, and forecasting of future motion of other actors. And just so you understand the magnitude, we're up against a fairly extraordinary feat in what humans do every day on the road.
So Kyle, switching to you, clearly you have talked, and we've talked about how autonomous vehicles are the future, even in trucking, because I like the phrasing you use. At the end of the day, every truck is a profit center, which is not the case for us buying cars, which is more of a consumption decision than an investment decision. You chose to partner and not do it yourself. I'm curious about the logic you used to come to that, that decision, that sourcing decision.
Well, that's really fairly simple. I think, over time, our vehicles have become more and more complex and are a combination of hardware and software. But even today, most vehicles, most commercial vehicles have automatic emergency braking and safety systems on them. But the level of complexity and the functionality and the level of precision that a level 4 and higher autonomous system has to have creates like Sterling has described, a tremendously complex solution, and really the amount of effort investment is really pretty huge, and it's beyond or it's quite different than our specialization today in design, manufacture, and support of vehicles. And so we've chosen to take the partner approach and to engage with the industry in a way that we provide vehicles and support them in their development, but ultimately our approach is to partner for the solution.
So I'm going to ask you about the same question. Kyle, if you could go first. What is the path to the future for an OEM? And obviously, Sterling, what's the path for the software company? How long is it going to take? What are the milestones that you're looking to achieve before you can sort of fully launch? And so the real question is, what needs to happen on the trucking side? What needs to happen on the software side?
Well, let's start with the trucking side. So one of the things that's really important is that today with a human driver, really the truck is controlled in an analog fashion through, the steering wheel, the pedals, the shift, and all of the switches that are on the dash of the vehicle. And in the future, in order to fully enable a robotic driver, the truck has to be completely controlled digitally. And so one of the very important investments that we're looking at today is that change to completely control the truck digitally. And once that capability is in place, it enables the integration of the robotic driver or the autonomous system. And so that's the next step. And in combination of the digitally controlled truck and the fully automated driver, you then have the solution, once fully validated, that can begin to commercialize.
Yeah, just, as I was preparing for this session, I was reading about Volkswagen. And one of the things they talked about was how they were held back in their process because they had outsourced so much of the manufacturing of the car with independent control systems. And software has this thing, you need to have an integrated architecture. And so their prior sourcing decisions, which had nothing to do with software, actually came back, I'm going to put words in their mouth, to haunt them. Do you worry about sort of your manufacturing vertical integration?
Well, I think the thing that's really important is that you can achieve a vertically integrated software solution in an entire control suite, but there has to be a very precise integration of all of the components for the vehicle. And really, if you're outsourcing or if you're working with partners and tier ones to accomplish those subsystems, they ultimately have to be involved in the process of bringing the vehicle together. It's something that we do today and something that we'll have to continue in the future. Obviously, the level of precision and the capabilities of that digitally controlled truck have to meet the requirements of the robotic driver.
Sure. Sterling, what's the path for software? You sort of alluded to it. Let's flesh that out a little more.
Yeah, just to be clear, it's hardware and software from the sensors, the compute. There are a number of things that get added. And Kyle's right. All of the challenges of bringing up the platform to meet the specification, the redundancies, the by-wire systems required, that's kind of one track. In parallel to that, there's a track of development of hardware. In particular, as it relates to trucking, one of the, I think, misconceptions in the industry is trucking is easier than ride sharing, right? And I think the reason that misconception comes about is, people look at driving on highway and they say, well, objectively, you're encountering fewer weird things, right? Certainly, you ought to be encountering fewer people pushing strollers and fewer bicycles and things like this. What I think that view fails to recognize is risk is the product of exposure and severity. And when you're operating in very low-speed environments where your exposure to some of these cases is higher, your severity is much, much lower. If you hit a pedestrian going at 10 miles an hour, it's very likely the pedestrian walks away from that. You hit them with a truck traveling at 75 miles an hour, and it's over. And so the severity is much, much higher. as is the human performance. So humans on highways perform much, much better than they do in urban settings for the very same reason, right? And so from a complexity perspective, you've kind of renormalized for highways, and you've added an additional element that is much higher severity for the vehicle. And so when it comes to, you know, your question about the development path, well, a critical element of this is development of sensing techniques that will allow you to see the kind of ranges that this application requires. And when you're driving a Class 8 truck pulling a 40,000-pound trailer, and you've got to stop for something to see up ahead of you in the road, it's insufficient that you have a traditional pulse modulated LiDAR that many of the self-driving companies have today, because those are only going to see on the order of 200 meters, and that's, you know, on a good reflective object. And so one of the things that we did as an investment as a company early on is we recognized that the industry was missing hardware to solve this problem, not just software. And so while we spooled up a very large software team and invested heavily in virtual development and techniques that moved beyond the traditional guess and check of put test vehicles on the road and see where you have to disengage, we simultaneously invested heavily in hardware development. And one of the key investments that we made was we purchased a company called Blackmore. Blackmore's been around for 15 years. They've been pushing forward the envelope on frequency modulated continuous wave LiDAR systems that are no longer subject, or that by nature of the mechanism used for encoding the signal, aren't subject to the range limitations imposed by eye safety requirements that pulse modulated LiDAR units are. And so, distinct and unique to the industry, we, post integration of the Blackmore team, built this into what we call First Light, which is the industry's only LiDAR that sees 400 plus meters out and gives instantaneous range and Doppler signals. And so with that, we believe that this is really, you know, to your question, okay, what's ahead and how do you develop for this? You have to develop the hardware. You have to give yourself a fighting chance, give the software a fighting chance that it can solve the problem on the hardware you've provided. And I think that's a key element for any of these systems is future-proof the hardware so that software has what it needs so it can take the next step.
That's really, you know, one of the things I think that gets lost in some of these discussions is how hard this problem is. It's the co-evolution of hardware and software and the co-evolution of the whole trucking industry. And I'll be polite to Kyle, which isn't necessarily the most youthful industry, right? But it's sort of fascinating to see sort of both of you working on this journey together. We have an interesting question. I'm not sure how you're going to answer it, but the question is, when do you expect the technology to be perfected? And you know, you've already alluded to sort of how much work remains to be done on the hardware and software side and on the trucking side, but is there such a thing as even as perfection in this business? Like, maybe the better answer, like,
I can take a stab, or Kyle, if you want. Let me take a first crack, and then Kyle, you can pile on with anything I've missed.
All right.
So perfection is a weird word here, right? In fact, one of the mantras that I had my team live by at Tesla when we built the autopilot program was don't let perfect be the enemy of the better, right? And better for us is safer than status quo. And so from the standpoint of how we can make a difference, I'm sure you've all heard the allegory of the little boy walking along the beach that was, you know, seeing starfish that were stranded and picked one up and threw it back in the ocean. And his dad said, you know, son, at this rate, you'll never make a difference. There's just too many starfish on this beach. And little boy turns to his dad as he throws another starfish in and says, made a difference for that one. Our view is we can make a difference for some, and we can expand that over time, right? And so in terms of path to market, in terms of what is good enough for us is better than human. If we achieve that milestone, if we're able to operate more safely than a human, it would be ethically the wrong thing for us to do to withhold that technology from market deployment, even if it makes a difference for exactly one starfish on exactly one trucking route, right? And the expansion over time will take on more and more. And so this is, you know, there's a very large ocean to boil as it relates to the distinctions between many different roadways and driving environments. We're going to take those one at a time, and we're starting with kind of the middle mile application and high volume trucking lanes. And so this is all about kind of the return on the initial investment with that first product, target it at where you can get to market most quickly and make the biggest difference, and then expand it over time. So I'm I'm attempting to dodge the question of when, because we, as a company, as Aurora, have been keen to be the kind of thought leaders on moderation as it relates to, look, don't get your hopes up that this is an immediate thing. It's going to take some time. Our current expectation is, we're a few years from deployments that will really start to sort of move the needle on the market. But I think it's notable that we're not a decade away from it, right? It's a few years, right? It's additional development on many of these tracks that we've described, the vehicle platform side, the hardware side, and the software side. But make no mistake, our expectation is ultimately we'll make the difference for a lot of starfish.
Kyle, I'm going to go to you real different, but I'm only going to give you 15 seconds to answer because we're running a little bit over and I like to be on time. But when we get to sort of maturity, whatever, the sort of the intermediate maturity, as like Sterling was alluding to, it's going to be a long, long process. Do you see autonomous software as a differentiator for PACCAR?
Absolutely. I think the future in terms of autonomous software is depends on how the technology bursts into the marketplace. But even if there are multiple providers of autonomous technology, there will be drastic distinctions between the capabilities. And so any way you cut it, once autonomous technology really matures in the marketplace and begins to be commercialized, it'll be very hard not to adopt it. And that's one of the reasons why we think it's so important to be involved. I think going back a little bit to Sterling's starfish concept, this is a really long journey, and the ocean is big to boil, and the deployment will start in the simpler cases and then grow over time. But there's no doubt that once it begins to grow and take hold, it's going to be very, very important for all transportation and all transportation participants to be involved.
So thank you, Sterling. Thank you, Kyle. That was incredibly informative and illustrative. This is one of those sectors that everybody cares about. Like, when is this going to happen? When can we get this technology? And I think we begin to understand the complexities of sort of developing the technology, both hardware and software, and also moving sort of an OEM along. And I think industrial digitization or digital industrialization is much harder than I think people anticipate. But there's incredible promise. So thank you, Sterling. Thank you, Kyle. We really appreciate your time with us today.